It is no longer news that Apache Airflow is one of the best workflow orchestration software out there. It's an open source tool and it is one of the best solutions out there. But what if you want to have a sprinkle of Apache Spark cluster, multiple programming languages like Python, Scala, and Java in the mix? How would you handle these kind of multiple dynamics? Well, in this project, I'll be showing you how you're going to be having a mix of this Apache Airflow, Apache Spark with master worker architecture, Docker, Java, Scala, and Python. So stay with me on this journey and let's get started. Why don't we start by creating a new project? I'll call the project Sparking Flow because I want it to have a representation of Spark and Airflow. So I'm going to call it Sparking Flow. I'll be using Python 3.11 and I'm going to be creating. Okay. Now, PyCharm is doing the initial bootstrapping. So once that is done, what I need to do in the terminal, I'll be creating some folders and files to serve as our base folders. Then we work our way up from there. So I'm going to start by creating DAG. So I'm going to say make directory DAGs, and then we're going to have a directory for jobs. Aside from that, we need our Docker file because we're going to be containerizing the project. Okay, so I'm going to have touch Airflow environment, Docker compose, YAML, and Docker file. And also I'm going to have a Docker ignore. Okay, so once these are done, the next thing that I need to do is to continue with the architecture of the system. So I'll go into the Docker compose and I'm going to just copy paste the architecture in there. So right now, to talk through them, I have services. And if you look at the services, I have 5 services. Okay. And each of the services, one is Spark Master, Spark Workers, Postgres, Web Server, and the Scheduler. The Spark Master and the Spark Worker, they are inheriting from Spark Common, which is the base image. And if you look at the Spark Common, it's have an image of Bitnami Spark latest and having a volume of jobs mapped to Bitnami Spark jobs on the container and then this network. The reason why I'm doing this is to apply a principle called don't repeat yourself, the dry. Okay, as much as possible, you want to minimize the code replications in your application. So once you change something somewhere, you don't keep changing it every other places. Okay, so aside that, having some properties that are different, something like the environment and the dependencies. And if you look at the command, I have my master command with this, and the worker command is this, which in the worker you have to pass in the master URL. Aside that, I have a Postgres DB. I'm using Postgres 14, but you can use any of the versions of Postgres that you like. Okay, doesn't really matter. So far it's Postgres 12 and above because of the dependencies. Okay. I have the environment and then the network. Then for the web server and the scheduler, they have the same properties majorly, and they are inheriting from Airflow common. Airflow common, the command is web server. In here, the command is this, where I'm doing a DB migration. I'm creating this user with the username of admin, first name Yusuf, last name Ganu, role is admin, email Scala and at gmail.com, then password is admin, Airflow is the scheduler to bring up the scheduler instance. And if you look at the Airflow common, is here. These are the build contexts. So they are inheriting from the Docker file, having an env with this username and password, and the volumes. These are the volumes that are mapped into that. And it's depending on Postgres, and then they have the same network. So that's the basic overview of the system architecture. So this is going to create the master worker architecture for us. on our Docker instance, as well as web scheduler and web server on Airflow, having a Postgres database as our backend. And just continue to the Docker file. And inside the Docker file, I'll just copy paste the Docker steps. So I'm going to have the inheritance is going to be pulling the image from 2.7, Python 3.11. I'm going to be switching to the root user to install the container dependencies. And it's important you have an OpenJDK in there because of the Spark cluster and the submission. Okay. So I'm submitting to this, and I'm switching back to user Airflow to install these dependencies. So we're going to be running these same dependencies on our local system by the time we want to start coding in our DAG. Then the last thing we need to do is inside our Airflow env, we need to just have our environment variables in there. So I'm going to have the load example is false. I'll be using local executor. In the past, if you followed this channel for some time, we've been using sequential executor. We've been using celery executor, and then now we've also currently using the local executor. In future projects, we are going to be attempting to use the Kubernetes executor. So stay tuned for that. And we are using the PostgreSDB, and the web server URL is this, and the secret key is this. Now, once these are set up, the only thing that I need to do next is just to exclude the venv, okay? And I have a folder I've created by PyCharm called PyCatch, and I have some other ones like asterisk.pyo. I think I need to exclude the git from there too, and maybe pyc. Okay, anything asterisk.pyc. All right, so once that is done, the next thing we want to do is spin up our instance and see if the environment is set up and ready to run. So I'm going to just close this, and I'll close that, and I'll close this. Good. So I'll just come back to my terminal, and I'll say docker compose up in detached mode. It takes a few seconds. Okay, so it looks like this is creating directly. So docker compose, I'll be doing down. So it needs to create the base image. So the reason why you're saying created directly without pulling the image is because I already wrote something like this before. Okay, so I just go back in there. I'm going to have docker compose up detached, then I have the flag of build so that I can rebuild the image, and it's not using the previous image from my previous project. So going back in there, I just added the flag of build, and you can see it's building everything again from the scratch. So you should see something related to this. But the reason why you're seeing some cache in here is because I already have some base image in my system. So right now, the containers are started, and let's see if everything is fine. So going back to the scheduler, in our scheduler, the scheduler is coming in, and the scheduler is ready to rock and roll. And in the web server, it says, of course, because this is the first time that you're running this. This is not going to be something recurrent. It's just for the first time anyways. So I'm just going to go back into my terminal. You can either restart it in here, start or restart, or go back into your terminal and just do docker compose or detached. Okay, and it's going to get it started again. And if you go back into the web server, then we should be having new installations. You can see them coming in there, and it's starting the G-Unicorn, which is the web server. On the UI, I'm just going to go to the UI, and you can see that in here, I'll just go to localhost 8080. And you can see that our Airflow instance is up and running. So let's test if the admin username and password is available and is set up properly. Admin. Okay, I'm going to sign in. And you can see that we have our Airflow set up, and you can see the cluster activity. The cluster is healthy and is ready to accept connections. So the next thing we want to do is we want to check if our Spark cluster also is up and running. So going back to our Docker, you can see we exposed 7077 as our submission port and 9090 as our web server UI. So if I go to this or click on this, or I go into my browser and I click localhost 9090 is the same. Just go to this URL and you'll be fine. So our Spark master is ready to rock and roll. It has a single worker, and this is the worker ID, and is currently alive with 1 gig memory and 2 cores. Good. So the next thing we want to do, I want to show you how you can add multiple workers in case you want to increase the compute power in the system. So going back in here, just come back to the Docker Compose, and applying the principle of dry, you might want to go back in here, extrapolate these properties outside of here, and then you can duplicate it multiple times, just having Spark worker 1, 2, 3, 4, as many as possible. Okay, so you just put this in something like an Airflow common like this, maybe Spark common worker, something like that, and then put the properties in there. Then you can inherit in the other workers. Okay, and that is how to get the architecture started. In the next section, we're going to be going into our DAG. So we've created the architecture right now. The next thing we want to do is to create our DAG where we are going to be submitting the multiple jobs in different languages. So if you want to, we're going to start with the Python, and then we move on to Scala and as well as Java. So let's proceed. So in the DAG section, just in your DAG, I'm just going to create a new file. I'm going to say Spark Airflow .py, and inside my Spark Airflow, I'm just going to delete this. In my Spark Airflow.py, I'm going to be importing the Airflow DAG. So for that to work, right now, if I do from Airflow import DAG, I'm going to be seeing an error because I haven't installed anything on my local system. If at all I've done anything, it's on the container. So I need to do the same so I don't see all the scribbles and errors on my system. So I'll just go back to my Docker file, and I'll just copy the command in here, and I'll just paste it here. Okay. So once that is done, I'll go back in here and I'll start writing my DAG. So basically, I'm going to be having my DAG. So I'm going to say DAG equals to DAG while that is running in the background. I'm going to have my DAG ID. It's going to be Sparking Flow. And the default arguments, default args, is going to be the owner, is going to be Yusuf Ghanil. The start date is going to be, I'll be using inbuilt function. You can use date time or something like that, but I'll just be using the inbuilt function. Okay, dates and days ago, I'll be using Y just to start from yesterday. And aside that, let's import this Airflow. So I'm going to say import Airflow. And in my schedule interval, I'm going to have daily. So it runs every day. And once this is done, the next thing we want to do is have our first DAG, which is going to be our Python job submission. Okay, so having that, I'm going to say, let me import the dummy. So I'm going to say from Airflow, the operators, the Python, import Python operator. Okay. So I'm going to say, to start, I'm going to have a Python operator, and it's going to have a task ID of start. The Python callable is going to be a lambda function, that does just one thing, says jobs started. Okay. Then going back in here, I'm just going to add a comma, dag equals to dag. So once that is done, this is going to print on the UI. By the time the job starts running, you're going to see on the UI in the logs saying job started. So the next thing we want to do is have our first job submission operator. So I'm going to come in here. I'm going to say Python job. It's going to be Spark submit operator, submit operator. Okay. And I'm going to have a task ID of, let's say, Python job. The connection ID is going to be, let's say, Spark con. Then our application is going to be inside our jobs, Python, and then let's say maybe word count job.py. All right. Then the DAG is going to be DAG. Good. So let's import the Spark operator. I'm just going to come in here and then import from there. So it's going to be importing from Airflow provider. By the way, this is only possible because of the installation we did. This is this Apache Airflow providers, Apache Spark. So if you want to read more, you can just go to the official documentation page and look up the Apache Spark provider module for more information. So going back, maybe sparking flow, I don't know. Yeah. Okay. And going back, we need to create our first job and then take care of this connection ID, because right now we don't have a connection ID called SparkCon. So we need to create one. Okay. So let's start with the jobs first. Then we work our way up from there. So inside my jobs, I'm going to say touch jobs, and inside there, I'm going to create Python. And there I'm going to have word count job.py. Okay. It says there's nothing like Python. Okay. So I'm going to say cd jobs, make directory, Python. And in here, I can just rerun that. Yeah, I'll just go back one step and just touch. Good. And in here, you can see that I have Python word count job. So opening the word count job. So this is where I'm going to be writing the word count code. So I'm going to just have my Spark submission script, which we've done in the previous video. If you check the cards above, you'll see a previous video where we dealt with this more extensively, and we even did some real-time streaming alongside. But aside from that, you can also enroll on one of my courses. It's also free on the website, so you can check the link in the description. So continuing, we are going to have from pyspark.sql import Spark session. So I'm going to have Spark. It's going to be Spark session dot builder. So I need to specify the application name and the context. Okay. So I'm going to have, let's say, Python word count. Okay. Then I'm going to say get or create. So what I want to do basically is I want to have a Spark job that basically counts the occurrence of every word in a single sentence. You can have multiple sentences and the rest, but this is just an example. So you can have a more complicated job and even a Spark stream running. What stops you from doing anything you like? So, but in this session, I'll just keep it simple. So because we are covering a large ground, so I'll keep it simple and just do a quick word count and we continue from there. So I'm going to have a text, which is going to be text. Is going to be, let's say, hello Spark, hello Python, hello Airflow, hello Docker, and hello Yusuf. All right. Then for us to have that, I'm going to do a split. So I'm going to have Spark context, Spark context. Okay. Then parallelize text dot split. So I'm going to be splitting on space. So I'm going to have word count. Okay, it's going to be words.map lambda. So I'm going to do word of word comma one, initialize every word with one. Then I go there and reduce by key for each word. So I'm going to have a lambda function of A and B to have A plus B. Simple stuff. Okay. Yeah, no, it's a lambda, not lambda, not lambda. Okay. I think if you understand what lambda means, it's going to be funny. Okay, but this is a lambda, not lambda. Okay. So I'm going to have for WC in word counts. Okay, dot collect, because this is an RDD that has been created. I'm just going to print WC 0 and WC 1. All right, and I'm going to say spark.stop. All right, so basically to just quickly talk through the mapping section there. So what I'm doing basically is to say, this is the text. All right, I'm splitting everything. Of course, if you understand basic Python, you know that this is going to split each of them into arrays. So we are going to have an array of LO, comma, LO, this inside the list, right? So after the splitting using the parallelize function, I'm going to be doing a mapping over this word, and each of the words will be initialized with one. So we have LO1, LO2, LO, something like that. Everything in there. So we have LO1, Spark 1, LO1, Python 1, LO1, Airflow 1 to the end. And at the end of the day, I'll be doing a reduce by. And what reduce does is it goes through all of the list and gets the key and the value, where you can do in real time, do an addition. So basically, I'm getting the key and the value, something like key 1, value 1. Okay, and I'm adding each of these key for that particular. So if you see LO the first time, it's going to say 1. LO the second time, 1 plus 1 to 2. So something like that. So LO is going to be LO 1, 2, 3, 4, 5. Yeah, and each of them we have each of the occurrences. Okay. Then at the end of the day, once I have my RDD, the next thing I want to do is print them on the UI. And I just want to say each of these, I'm going to do a collection of the RDD, and I'm going to print them. So which is going to be, the word, which is the key, and the value. Okay. And at the end of the day, I stop. So let's see if we can submit this to our Spark cluster. So in our Spark Airflow in here, we already made reference to jobs, Python, and our word count job. So the next thing we want to do is set up our Spark connection. We've not done that yet, so let's do that. So on the UI, I go back into my cluster in here, my Airflow. I go back into the connection, and in my connection, I'm going to do an addition. So I'm going to go into this place and look for my Spark, and you can see my Spark in here. I'll call this Spark con, which is the connection. You can say Spark cluster UR connection details. You can call it anything you like. And coming back in here, so I'm going to go into let's say Docker compose up. So I'm going to say, where is my Spark master? This is my Spark master. So I'm going to copy this as my Spark master. And coming back in here, I'm going to have Spark master. And the port is 7077. 7077. I would really advise you don't use this IP address, because by default, Docker uses DHCP, which is the dynamic assignment of the IP address by the time you are spinning up. So the same IP address you use now may be different the next time you are initializing your Docker instance. So it is very important that you don't use the IP address, you use the container name. And how do you get the container name? You can come back in here and you'll see the Spark master container name, but it's saying Spark and Flow Spark master container name. By the way, you can also get that if you do Docker PS. You will see the Dockers that are the Docker instances that are running on your system. You can see them in here, which is the Spark and Flow Spark Master 1. Or you can also do Docker inspect to see the more properties of the instance of the Docker that has been created. Now, once that is done, I'll just come back to the UI again and save. All right. So I have my Spark con with the host, the port. I'm not encrypting anything, and I'm not doing any other extra encryption. So let's go back in here. I have my Spark Airflow, okay, which is this guy, the DAG that I have in here. And my first job, let's see if it is attached to that. So if I click on the Spark Airflow, it's going to go in there, and you can see each of the operators and the tasks that has been instantiated. You can see I have my start Python job. So I need to have an end too. So I'm going to have end. I'll just copy this and paste there, and I'm going to say end. And jobs completed successfully. All right. And at the end of the day, I'm going to have start Python job and end. This is not start, this is end. Good. So right now I can have my three instances, my three jobs and operators linked together. So I have on the UI, if I do a refresh in here, you have the start, Python job, and end. And if you look at the graph, they are connected to each other. Well, they should be connected. I think I'll just start. This is right, but for some reason, the UI is not linking them. So let's see why. If I click on this, interesting. The linking is done now. Yeah, so the first submission is going on, and let's see if everything is all good. All right, so we have a start, which is successful, but the Spark submit failed. Let's see why in the logs. It says task is not able to run. And why is that? So let's see why. And in here, okay, no job submission. So we are not able to reach the Spark master. And let's come back into our Docker Compose. What would we call the name? We call the name of our Spark master Spark master. Yep. And I think it's the naming that was wrong. So I'll just change the cluster name in here, connections, and edit this. And you have, I think maybe, yeah, Spark master. Okay, so it is done. So the reason why is because we were using the wrong cluster name. So it's supposed to be Spark master, not the full cluster name. So anyways, right now our Spark job submission is successful, and we have our first job running. So if you go into this and you go into the logs, if I click on the Python job and I go into the logs, you can see that I have Python 1, Airflow 1, Hello is 5, Spark is 1, and Yusuf is 1. Something like that works as expected. Good. So the next thing we want to do is have our Scala instance. All right. So we are going to be installing Scala into our system and then building a simple project with Scala. All right. So going back into the code in here. So I'm using a Mac, but the installation process is the same. Well, roughly the same for all of the Unix systems and Linux. But for something like Windows, you have to go through the specific documentation to get them installed on your system. So going back in here, I already have the documentation in here. So if you want to install Scala on your system, so the first thing you need to do, if you are using a Mac, you can use the SDK man or the Homebrew. So I already installed this with Brew install. I'm using Homebrew anyways. And for Windows, you have to either install the MSI or use the Chocolatey or Scoop. So the same way for Linux, Deb and RPM, you use this installation packages, and if you want to install the zip and maybe build from the sources from there, you can continue from that. So that's how you do it, and you can install the different versions separately. You can install them by clicking on the MSI or the TARS file or the zip file. Okay, so I already did that earlier. So if I did brew install SBT, you can see that I already did that. I'm not going to be doing that again. So you can also check your SBT version, so to see the version of the Scala that you're currently running. So I'm running 1.97. Okay, so now let's create our first Scala project. So the next thing we want to do is go into our jobs. So I'm going to create a new directory. I'm going to say make directory jobs, and I'll call it Scala. So I have a Scala directory in here. So I'm going to touch jobs Scala, and I'll say word count.scala. Okay, so I have my Scala job in here. But one of the bootstrapping process or getting your Scala project ready is to have your build.sbt file, okay, where you're going to be writing the dependencies and the properties of the projects you are creating. So I'm going to have, again, instead of build that, I'm going to have build.sbt. Good. Now, the next thing we want to do is inside the build.sbt, we are going to start by having the dependencies. So I'm going to say the name of this project is going to be word count. Okay, that's basic stuff. The version is going to be version 0.1. The Scala version is the Scala version is going to be 2. The one that I'll be using in the container is 2.1.8. Then the library dependencies, I'm going to do library dependencies plus equals, I'm going to have org.apache.spark. Then I'm going to be having Spark SQL, okay, and the version for that is 3.2.1. Good. So you can play around the dependencies and the versions, but I find this working for me, so I'm going to leave it at that. So this is the dependency. Let me just double check that everything is fine. Okay, good. So my build.sbt is fine, and I'm ready to build my project, but I haven't written anything in my word count project. So let's do that. Okay. So in my word count, I'm going to go into the word count. I'm going to write the code in here. I'm going to say apache.spark.sql.session Spark session, rather. I'm going to have my class. Well, some people say Scala is the Python, Java version of Python. So I'm going to say dev main, okay, the args array of string, basically, just like you have a main class of Java, but you are writing the Java in Python. Okay, so I'm going to have a value of my Spark, just like I had in my word count job, something like this. I'm going to do the same in my Scala, and coming back in here, I'm going to say Spark session dot builder dot app name is going to be word count. Yeah, okay, and the master is going to be Spark. Well, this is extra, but you don't have to dynamic specifically say this is the Spark master, but I'll do that. Get or create. Okay, just like I did in the word count job. Okay, so you can also do the same with the master in here, or you can just leave it at that, but I'll leave it like this. Then I'm going to have val sc equals to spark dot spark context. By the way, if you are new to Scala or you are looking to get some more information about Scala, you can check the link in the description and you can go to the course for more information. All right. So I have some in-depth tutorial on how to navigate the world of Scala and how to get started with Scala. So I have val and the text data and the sc.parallelize. Okay, parallelize. So I'm going to be saying list of hello world, hello Spark, comma hello Docker, hello Scala, and of course hello Yusuf. All right, hello world, Spark, Docker, Scala, and Yusuf. All right, so at the end of the day, I'm going to close that and go back into this. So I'm going to have my value of counts, which is going to be text data that I have in here. Okay, and I'm doing a flat map in there where I'm having a line of a line dot split. Okay, split on space, of course, just like we did before. Then aside that, I'll be doing a mapping dot map, and I'm mapping each word to word comma one, and I'm doing a reduce by key. I'm going to be reducing by the first one plus the second one. Excellent. You can see the difference. There's a little difference between the way you write the Scala and Python, but they are kind of similar. Like I said, some people refer to Scala as the Java version of Python. Well, you can call it that or not. So yeah, going back into the code, we have my reduce by key. The same thing that I had in here is the same thing that I'm repeating in here, but in different syntax anyway. So I have my count.collect, count.collect. Then say for each, I'm going to be doing a print line. Then this is what this is going to be doing, just printing the words, word count directly. Okay. Then at the end of the day, I do spark.stop. Spark session builder app name, get or create, Spark context. Okay, and parallelize this, list that, flat map this, word that, reduce this, and then collect that. Excellent. So let's see if our Spark is ready to be rock and roll. So let's take this for a spin. All right. So how do you build a Spark, a Scala project? So the first thing you need to do is go to the terminal. In here, you can say, because you've already installed the SBT on your system, I'm just going to write SBT. Okay, I can say SBT compile, and this is going to create the compile version of the code into this. So I have my execution. So I'm having this, and you can see that is executing in batch mode, and the total time is this. And if you look into the directory in here, there's nothing yet. Okay, so I can say sbt.package. Now this is going to generate the jar equivalent, the jar file from this code for me that I can use to submit to my Spark cluster. So, and in here you can see, oh no, I'm compiling into the root directory. So that's wrong. I should be in the Scala directory. Okay, so I should say jobs, okay, Scala, and I'm going to do sbt compile again, and you should see this time around that in this compile directory it's going to have some data in there. Okay, and so it's doing some installations and the rest there, and compilation rather, and at the end of the day it's done. And you can see inside my Scala project I have a project and I have a target. Lovely. So the next thing that I want to do is sbt package. So this is going to generate a jar file for me. All right, so it's done, and you can see in the target I have Scala 2.12, which is the one that I'm using in here. Scala 2.12. You can see in here I have my word count 21201. Okay, so I'm going to copy the path reference. So I'm going to just say copy from the root, and coming back in here, I'll just reduce this a little bit. And inside here, I'm going to say Scala job is going to be Spark submit operator. Excuse me. Spark submit operator. I'm going to have the task ID. It's going to be, let's say, Scala job. And then the connection ID is going to be Spark on. The application is going to be in the directory that I copied, this guy. Okay. Then I'm going to have a Java class. So it recognize the, sorry, I don't need the Java class. This is Scala. We've not reached the Java section there. Okay, so I'm going to have the application, and then the last thing that I'm going to be needing is the DAG. DAG equals to DAG. Good. So that is done. We just need to add this to our list. So we change this to a list, and it's going to be Python job, and then we have a Scala job, and we save that. So going back to the UI, I'm going to just put this just in here. You can see the link in the description too. So in the graph, my sparking flow, you can see that I have another guy in here, but for some reason it's not attaching that to it. So if I trigger this, we should have the latest, okay, been triggered there and added. And if I click on the first one, you can see that interesting. So let's see why. I have my Scala job in here, okay, and going back in here, I refresh this, and there's an error. And why is that? So if I click on this, yeah, okay, it's corrected now, but I don't know, for some reasons this keeps messing up. I think it could be, I don't know, maybe a bug or something. So you can see the spark in here, but there's a failure. So let's see why it's failed. So if I go in there, it says task is not able to run. Okay, it says all success, but there's something failing. All right, so let's see why it is failing. So going back in here, I have my Scala job. It is failing. So going back, I have Scala job and Spark con, and I'm having Scala 2.1201 and that. Interestingly, the job compiled successfully and it was submitted and ran successfully. But for some reasons initially, it wasn't running. Even though I didn't change anything, I just I did a refresh, but that's interesting. So it looks like probably it has not finished synchronization with the Docker instance, maybe that could be the reason why. But for some reasons, I don't know, I just did a refresh and it's working. So you might want to take note of that. I didn't change anything, and so suddenly, just after a refresh, the job is working fine. So yeah, so we go into the next step. So in this section, we're going to be writing our Java file, our Java package, to do the same thing in Java. And you will see how we can, generate the Python jobs and submit it to the Spark cluster. We've done the same for the Scala, created a simple project, generated J out of that, and then submitted it to our Spark cluster. We want to do the same thing for Java language. So I'll be using the Maven package to create a new project, and we are going to be taking it up from there. So going back in here, so I'm going to be having inside my Scala in here, I'm just going to leave that out of the way, and I'm going to go one step out, two steps out. So I'm going to be making a directory. I'll call it jobs.java. Okay. So I'm going to go into the directory of Java, cd jobs, and Java. Okay. So inside my Java directory, I'm going to be initializing a Maven project. So I'll be using Maven. You can use a Gradle, or you can use pom.xml to create a new project. Okay. So I'll just be using Maven as my archetype. Okay. So I'm going to be saying Maven archetype, and I'm going to say archetype generate. The group ID is going to become ID Spark. Artifact is going to be Spark job. I'm going to say the artifact ID is Maven archetype quick start, and the interactive mode is going to be false. All right. So I'm going to just press enter, and inside the Java directory, the Maven is going to generate a project for me that I can use to create this code. So you can see that in here, I have my Java file in here. By the way, you need to have Maven installed on your system and Java also installed. So if you haven't done that, let me just get you the link where you can do the installation. So in here, you can go to the maven.apache.org for the installation, and you will see that this is how to do the unzipping, or if you are doing a tile unzipping that. But before that, you must make sure that the required dependencies are done. You have to have a Java home and in your system. But if you're using something like maybe homebrew, you can do some, brew install Maven or something like that. So just look up the documentation for more information on how to get it down onto your system and how to run it on your system. Okay, but this is the link, so you can go in there for that to get more information. So I just use the Maven to generate the project, and inside my Java, you can see that I have my Spark job. I have an SRC in here, and I have a main, and the directory that I have is com.scholar.spark. So it's creating a basic app for me, which is where I'm having my app main. So I'm going to rename this into refactor. I'm going to rename this to word count job. Okay, and then aside from that, I'm going to change this to word count job. So if you're a Java developer, you know that you can't have the main class different from the name of the file. So it's important to be in the same name. Okay. So going forward, we are going to go into the pom.xml. Where's my, pom.xml. I have this as I'm going to be adjusting, I'm doing a copy pasting in there. So if you want to get the full code, you can just get it from the repository in the link in the description. So I'm just going to copy the build section. So the system recognizes how to build that. So it's going to be using the org.apache Maven plugins, Maven compiler plugin, which is I'm currently using the 3.81. The source and the target is 1.8 for the configuration. And the dependencies, I have the JUnit right now as the basic dependency. I just need to add a single dependency of Spark. So in here, I'm going to have a Spark SQL dependency. So if you go in here, I have Spark SQL dependency of 2.12, 3.21. And if you want to get how I get that, you can go into the not com dot. This is I'm using the com.org.apache, so you can type org.apache dot spark, and you can see that I have my Spark SQL in here. So I'm using the 3.2.1, so which is this guy 3.2.1, and I copied that from here. So if you're using the Maven, you click on the Maven and you can get this same thing into your project. So again, if I copy this and I replace this dependency, you can see that it's exactly the same. Okay. All right. So that is done. And I think, yeah, we are ready to rock and roll and build our project. Okay. So once this is done, the next thing we want to do is go into our Spark job. Okay. And write our word count code. So inside the word count code, I'm going to have, I'm going to say the Spark conf is going to be coming from new Spark conf dot set app name. It's going to be word count job. Then dot set master. I'll be using the local. Okay. Then I need to import the Spark conf. I'll be importing the Spark conf from what did I just do? Yeah, import org.apache.spark.sparkconf. Okay, and I'll end this. So it is very important to use an IDE that is friendly, because I already have an idea of how this is going to look like. You might want to use something like an IDE, IntelliJ IDEA or Eclipse or any other IDE that is more suitable for Java programming because of the IntelliSense and the rest. Okay, so I'm just going to have after that, I'm going to have my Java Spark context, which is the Spark context. I'm going to say new Java Spark context, and I'm going to be passing the Spark configuration into that. So I'm going to have an add coded text in here, add coded text in here. So it's going to be a string of text. It's going to be, let's say, hello world. At the end of the day, I had that. Hello world, hello Spark, hello Docker, hello Yusuf, and hello Java. Okay, then I'm going to have a list of string in here to say my data is going to be an arrays as a list. Okay, I'm going to be splitting that split into by space, and yeah, and once that is done, I'm going to just import the list and the array. So I'm going to be importing that from Java util, java.util.arrays, import java.util.list. Okay, and once that is done, the next thing that I want to do is going to be parallelize the data. So I'm going to have java rdd. Okay, string is going to be lines. It's going to be sc.parallelize. I'm going to be parallelizing the data. So I'm going to be importing the Java RDD, and it's going to be coming from org.apache.spark.api.java RDD. Okay, and the Java Spark context is going to be coming from the same package. Also, I haven't imported that. Yeah. Aside this, once this is done, the next thing that I want to do is I'm going to be split into words and perform the word count. Okay, so I'm going to be using Java pair RDD for that, to have a string and an integer. So this is something like a dictionary in Java, well, tuple or something like that in other languages. Okay, so I'm going to have this imported from the same package name. In here, I'm just going to import this Java pair RDD. So I'm going to be doing lines.map, flat map. So I'm going to be saying map this as arrays as a list, then space. Well, I'm going to be importing that shortly as okay, and dot iterator. So the space, I'm going to be doing a declaration in here to say private static final pattern of a space is going to be pattern dot compile. So I'll be compiling that as a space. So let's import that java util dot regex dot pattern. Okay, iterator, thank you. Then aside that, I'm going to be doing a map to pair. So once I've done the flat mapping, I'm going to be mapping that into a tuple of word and one. So to initialize each of them to one, I'm going to be doing a reduce by key. and integer. That'll be summing them up. And at the end of the day, I'm going to come back into this and I'm going to say collect and print the word count results. So I'm going to say the tuple 2, yeah, I haven't imported that. So let's import that. So it's going to be imported from import Scala dot tuple 2. Okay. And yeah, tuple 2 is going to be a tuple of a string and an integer. And the output is going to be the variable name. I'm going to do count.collect. And I'm going to talk through them and explain this a little bit more. Just let me finish this code. Tuple 2 is going to be a parameter of this. I'm going to say tuple and then the output. So just do a system.out, system.out.print line the tuple.1 plus a space if you like, or comma, or I'm just putting this in there, and plus tuple.2. Okay, and that's it. And at the end of the day, I just do spark.close, which is the close the context. Okay, so let me just talk through each of them and what I just did in the code. So I'm creating a Spark configuration with the name and I'm setting the master local. Okay, I can set the master to the same. Okay, so the Java, I'm creating a Spark context with this, which is the SC, and the string of the text that I want to count is this, and I'm going to be I forgot that. Okay, so then I'm going to have a list of string as data, so I'm going to split all of this and convert them to list, array list. Okay, and from there I'm going to have a Java RDD and then do a parallelization on the data, and then do a Java pair to do a mapping and map them to pair to initialize them to 1, just like we did in our Scala in here and in our Python in here, just like we did the lambda function in here. Then going back in here, I'm doing the reduce by key, and then I'm doing the integer sum on that keyword. Okay. Then once that is done, the next thing that I want to do, I have an output in here, which I'm collecting from count. The same way I can have my count.collect inside here just to make it a little bit more readable. That's why I'm having it here. So my tuple 2 that I declared in here is going to have a string and an integer, just like I declared it. So I'm having more like a variable or parameter to say string and integer in here. And each of them, you're going to print the string and you're going to be printing the integer. So the underscore 1 is the first value in the tuple and the second value in the tuple. So I'm going to say hello column 1, hello column 2. You can put a space, comma, or something like that, anything you like in there. And once that is done, I just need to import. Let's see if all my imports are fine. I have my arrays, regular expressions, and my Scala.tuple. Let's move this up. And we should be good. Okay, and the next thing we want to do is compile this with Maven to see if everything is fine before we continue. So I'm going to go into the terminal again, and I'm going to say in here maven.compile, maven compile. And this is going to compile for me. And let's see, it says, let's say maven clean, install, and U, because of the dependencies. So it says the goal, there is no pump. Yeah, we are not in the right directory. So I'm going to go into the Spark job and we have my pump.xml in here. So I'm just going to do a clean installation in here. So to resolve the dependencies and get them into the system. So right now it's downloading the required dependencies that I added into my pom.xml. So yeah, it's coming up. Lovely. And yeah, it's recompiling, but there's an error. So it says in my one word count job in line 38, there's an expected closing bracket. So line 38, I'm expecting a closing bracket in there. So let's see why. Where is my iterator? In here. So my iterator is here, so I need to close this. Yeah. Because I'm not closing this flat map. Okay. So I'll just do a clean install again for, yeah, there's no need to do clean install. I should just compile directly, but it's fine. And Maven compile. These are simple errors that could be caught by the IDE, but it's still taking me some time to fix it. So let's see. I didn't close this also, and I think that should fix that. So it says variable counts is not found. And let's see, where's our count? Yeah, I have counts. I'm using count in here. So compile again. Lovely. Now our compilation is done. Even though I'm here using IDE, IntelliJ IDE or other IDE that's Java supported, I'm using PyCharm, but I'm still able to pull it through anyways. Yay! Okay, so eventually we've been able to build our project and it's successful. The next thing we want to do is package it. Maven the package. So not Maven the package, is Maven package. Okay. So this is going to generate the jar file for us. And going back, it's running the test, no test, so it's fine. So it's creating the package inside this directory. And if you look at the source and inside the target, you see it inside here. Okay, so I'll just copy this. I have jobs. I'll just copy this. Okay, and inside my Spark Airflow, the DAG, I'm going to have Java job is going to be a Spark submit operator. And I'm going to have a task ID is going to be Java job. Connection ID is going to be Spark con. The application is going to be this that I copied from here in the terminal. Okay. And the last thing is DAG equals to DAG. Lovely. So at the end of the day, I'm going to add it to my list in here to say Java job. Excellent. So going back into the UI, I've just moved this into this so I can add it to the terminal, to the link in the description. Okay. So I'll just do a refresh. We're not going to do the same mistake we did the last time. We just wait a few seconds for the synchronization to be done between the code and the container on Docker. Okay, just a few seconds more, and I'll do a refresh again to see that the three are now mapped. So I have my Scala, Python, and Java. The three are now mapped, and I can now run. So let's rerun that to see if everything is okay. Okay, so it's running. The three jobs are triggered at the same time. And I'm excited. Okay. All right, Java failed. Why is that? Okay, let's see in the logs, why did it fail? He said, yeah, I couldn't find the main class. Interesting. So let's fix that. Going back into my Java, I have my Java class in here. I just need to add a Java class. And the Java class is going to be this guy. I'll just go back into my word count Java in here, copy the package name, com.s scholar.spark. So I'll just paste that, and the class, the main class name, which is the word count job, I'll copy that and then dot word count. Okay, and that is my Java class, and that should fix it. I'll just do a refresh in here and we should be good. So by the way, let's even see how these jobs are running on the UI. So if I go to the Spark cluster and if I refresh this, and you can see that one is waiting and this one is running. And we have a Python word count. This is our Scala. And then the next one is this. Okay. So we still have two running, which is fine. Lovely. So the three are done running. And you can see them in here. Okay, maybe not done. Yeah, it's done. So the three are done running. And if you click on the Python jobs and you go to the logs, you see the outputs in here. And in the Scala, you see the output in here. Lovely. And in the Java, you see the output in here. So that is how to create your Python job, Scala job, and Java job. Like I said, you don't have to limit it to just the three programming languages. You can use any language so far you have an entry point into that, and you can generate something like a jar file or even a Python output from there, and you can submit it to the Spark cluster. So just look at the documentation for the supported extensions, something like if you are using something like an Elixir package or something like that, see if it is supported before you do that. But so for now, we've been able to accomplish the objective of this video. To do a recap of what we've done so far, we've been able to set up our Spark cluster, the master worker architecture, even though we are using a single worker, but we are still able to set up our master worker architecture. Then from there, we were able to set up our web server and the scheduler for Airflow. We were able to create our Python job and submit it to the Spark cluster with Apache Airflow. And aside that, we were able to create a Scala job, Scala project. We're able to create a Scala project, write our Scala job, and submit it to the Spark cluster. The same thing for Java, creating a Maven project and writing our Java code to submit the job to the Spark cluster. Eventually, I also showed you how you can generate and compile, the code from Maven, code from Scala, and generate a Java file from there. If you like this video, smash the subscribe button, like and share for wider outreach. Thank you very much for joining, and I'll see you in the next one.